For our ISM Group Project final, we chose to do the topic of robotics in the workforce. Nicole will start with the overview and the history of robotics. Brad will follow up with the relevant components involved. I will be doing the robotics business, uses, and implications. Jason will be speaking about the relevant costs, benefits, and risks, and Jason will close with the future trends of robotics.
I'm going to be talking about what smart robots are. Smart robots are systems that use machine learning to do tasks humans would otherwise perform. The robots haven't just landed in workplace. They're expanding skills, moving up in the corporate ladder, showing some awesome productivity and retention rates, and increasingly shoving aside their human counterparts. The number of types of tasks that can be automated and augmented by software, robots, and other small machines are rapidly increasing. Smart robots have the capacity for not only manual labor but cognitive tasks. Experts are warning that skilled jobs will soon start to disappear because of the rise of artificial intelligence. Robots are likely to perform 45% of manufacturing by 2025 versus just 10% today, according to a study by Bank of America. The most obvious impact of industrial mechanization is that it eliminates many unskilled job positions. This has especially been the case for the United States and Japan, two countries that illuminate important factors of robot takeover. The price of robots and computers have fallen, making them even more attractive to employers. Next is a brief history and timeline of development. Robots are an indispensable part of today's large manufacturing industries. These intelligent machines have taken over many of the tasks requiring high precision, speed, and endurance. They are becoming increasingly smarter, more flexible, and automation with capability to make decisions and work independently of humans. They began in the early industrial robotics and manufacturing from 1954 to 1979. The first programmable robot is designed by George Devol. The first industrial robot was online in a General Motors automobile factory in New Jersey. Next was the robotic arm, also known as the silver arm, that performs small parts of assembly by using feedback from touch and pressure sensors, which was designed. Early industrial robots have limited intelligence, autonomy, and operational degrees of freedom. They were mostly designed to perform one or two sets of repetitive tasks in a high-controlled environment. Next is the modern industrial robots, which is from 1980 to present day. From 1980, industrial robots began to make larger numbers, with a new robot being introduced in the market at the rate of a month. These robots are microprocessor controlled and are smarter and have higher degree of operational freedom. The newest robots are the largest growing technological devices in the world. They perform many functions ranging from space exploration to entertainment.
Today is robots in the workplace.
Robots can be used in any situation for any purpose, but are mostly used for industrial reasons.
These robots are specifically called industrial robots,
Fears
and
that
they consist of a variety of high-tech components which are designed for accuracy, speed, and convenience of operation. The main parts of the robot are the controller arm, end effector, drive, and sensor. The controller, which is a pretty important part, is the brain of the industrial robotic arm. This allows the parts of the robot to operate together. It works as a computer and allows it to connect to other systems so that they can all work together and communicate to each other. The way it operates is through a set of instructions, which is through its programming. The program is inputted with a teach pendant, which I'm going to get into a little bit later. The next part is the main body or the arm of the robot. These can vary a lot in shape and size depending on what it's building or what it's going through. The industrial robot arm is the part that positions the end effector, which is the hand of the robot. But the arm is what makes it twist, move, and get the end effector in the exact right spot. Many industrial robots in factories today are 6-axis robots, which means they have a huge degrees of freedom of which it can move. But next is the end effector, which is what I said, the hand of the robot. This is what actually picks up the parts and the tools that it's going to be using. It uses these to pick up and manage the movement of items in accordance with the design parameters, which it gets through its programming. These are designed specifically to handle desired parts and move in the intended path. They can be accessories for welding processes or guns for painting purposes. The end effectors can vary in many ways. They could be a magnet, they could be a vacuum, they could be a gripper, which grippers can vary from 2-finger to 3 fingers. The 2 fingers is just your general picking up anything, which is basically your thumb and index finger. The 3 fingers is more for rounder objects which need revolving and to be spun. But the next part I'm going to be talking about is the drive of the robot, which is the engine or motor that moves the links into their designated position. This is like the joints of the robot, of your arm. This is how it twists and moves and is able to get to the desired spot. The type of drives that these robots use are either hydraulic, electric, or pneumatic. The hydraulic drive systems are there when you need to have great speed and strength for the bigger parts, like car parts or something. An electric system gives a robot with less speed and strength for smaller things. Pneumatic drives are used for smaller robots and have fewer axes of movement, which could be a 3-axis robot, which is just forward, backwards, up and down, or sideways. These drives are usually periodically inspected for wear and tear and replaced pretty commonly. But the next part is the sensor, which is another important part because these robots are lined up next to each other along an assembly line, and these are what gives feedback about its environment. These sensors collect information and allow the robots to work closely together without bumping into each other. They also can scan and know which parts it's going to pick up and know which parts to ignore. So those are the main parts of the robot. So what I was going back to earlier was the teach method, which is how it is programmed, and over 90% of industrial robots use the teach method. And these are just basically the programmer uses a joystick or buttons to teach the pendant. So it goes through its modes of movement, and while this is going on, the programming system is all recording each movement, each twist, each part it picks up. This is all being taught to the robot so it knows how to operate. And this is how these robots work together and how the manufacturing process was made a lot faster and more efficiently.
My name is Anthony Massey, and I will be covering a few of the business uses and implications of the robotics industry. Robotics are now being used in typical everyday life, from farmer to factory worker and to even soldier. There's now an estimated 250,000 plus robots working in factories across the country, and while fears of these robots taking our jobs still exists, the unemployment rate is actually dropping. More companies are using robotics to not only increase productivity, but also to cut costs. One example of this is a Japanese company based out of Kyoto, Japan. This company will use the robots in what they call their indoor robotics farm to harvest about 30,000 heads of lettuce every day. With climate change and droughts on the rise, many countries are looking forward to the new and innovative breakthrough the company has to offer. Not only has robotics helped this company in more ways than one, Quiet Logistics' invention, the Petite Locust robot, is a robot that will work alongside humans to retrieve and seal orders in warehouses across the country. The Petite Locust robot is expected to increase productivity in warehouses by 800%. It is truly amazing how productive these robots are, and because of that, North American shipments in 2016 reached almost 35,000, valued at about $1.9 billion, a whopping 10% increase from 2015. Of these robots in the workforce, the automotive sector accounted for 60% of new industrial robot installations, becoming the leading buyer of robotics in the country. Now that you know a few examples of the business uses of robotics in the workforce, it's time to move on to the implications. Robots in the workforce, especially in assembly lines around the country, are growing at an exponential rate every year. As you can recall, it grew 10% in 2016 alone. However, experts say that robotics are on the cusp of a major shift. We are now familiar with robots, such as the large robotic arms of the automotive industry, quickly piecing together a car faster than a human could ever do, but we are soon to see a large merging with robots and humans in everyday life. Antonio Pelaez, a sociology professor at Spain's National Distance Learning University, states in his research that just as we depend upon mobile phones and cars in our everyday lives today, the next 15 years we will see a mass hybridization between humans and robots. He also says soon that our relationship with them will become more constant and a commonplace. Just as Professor Pelaez and many other researchers state, robots are predicted to move beyond their current cage of the assembly line into a much broader range of activities. Some examples of this we see happening now are in robots such as the automatic farming robots, the Da Vinci robotic surgery system, which you can see on the screen, and warehouse robots such as the Petite Locust robot. Robotics are exponentially increasing in the workplace, and it's only a matter of time before they enter other aspects of our lives. Thank you for listening, and I hope you can take something away from my section on the business uses and implications of robotics. I am now going to pass it on to Jason.
Hi, my name is Jason Mann, and I'll be talking about the relevant costs, benefits, and risks of robots in the workforce. Cost: economically viable and efficient. If you doubt the march of worker-replacing technology, look at Foxconn, the world's largest contract manufacturer. It employs more than 1 million workers in China. In 2011, the company installed 10,000 robots called Foxbots. Today, the company is installing them at a rate of 30,000 per year. Each robot costs about $20,000 and is used to perform routine jobs such as spraying, welding, and assembly. On June 26, 2013, Terry Gu, Foxcom's CEO, told his annual meeting that we have over 1 million workers. In the future, we will add 1 million robotic workers. This means, of course, that the company will avoid hiring those next million human workers. Imagine what a Foxbot will soon be able to do if Moore's Law holds steady, and we continue to see performance leaps of 40% per year. Baxter, a $22,000 robot that just got a software upgrade, is being produced in quantities of 500 per year. A few years from now, a much smarter Baxter, produced in quantities of 10,000, might cost less than $5,000. At that price, even the lowest paid workers in the least developed countries might not be able to compete. Next, I'll be speaking about the benefits. Economic opportunity for entrepreneurs within the field. Technological progress has always displaced workers, but it also has created new opportunities for human employment at an even faster rate. This time, things may be very different, especially as the Internet of Things takes the human factor out of so many transactions and decisions. The second economy, the term used by economist Brian Arthur to describe the portion of the economy where computers transact business only with other computers, is upon us. It is quite simply the virtual economy, and one of the main byproducts is the replacement of workers with intelligent machines powered by sophisticated code. This booming second economy is brimming with optimistic entrepreneurs and already spawning a new generation of billionaires. In fact, the booming second economy will probably drive much of the economic growth in the coming decades. And there is even more sobering news. Arthur speculates that in little more than 10 years, 2025, the second economy may be as large as the original first economy was in 1995, about 7.6 trillion. Lastly, I'll be speaking about the risks. Reduction of no in low-skilled workforce. The technology of the past, by replacing human muscle, increased the value of human effort, and in the process drove rapid economic progress. Those of the future, by substituting for man's sense and brain, will accelerate that process, but at the risk of creating millions of citizens who are simply unable to contribute economically, and with greater damage to an already declining middle class. Consider the numbers for information storage density in computer memory. Between 1960 and 2003, those densities increased by a factor of 5 million, at times progressing at a rate of 60% per year. At the same time, true to Moore's law, semiconductor technology has been progressing at a 40% rate for more than 50 years. These rates of progress have embedded in the creation of intelligent machines, from robots to automobiles to drones, that will soon dominate the global economy, and in the process drive down the value of human labor with an astonishing speed. This is why we will soon be looking at hordes of citizens with zero economic value. Figuring out how to deal with the impact of this development will be the greatest challenge facing free market economics in this century.
I'll be talking about the future trends in robots. The future trends of robotics in manufacturing is extremely exciting. Robots are the future of the world and are being made to work side by side with humans. First, we get into increasing ease of use, deployment, and maintenance. Some of the issues that manufacturers have encountered while looking at the option of buying robots to help with manufacturing is the issue of programming and designing robotic systems. Each task in manufacturing can be different, so programming robots to be able to do different tasks has been a challenge for companies that are trying to sell these robots to the manufacturers. Presently, each robot has to be programmed for one specific task, and it can only do that one task. Robotic companies are working on fixing this issue, so in the future, robots are able to do more than one task. How they plan on doing this is installing algorithms and self-learning programs in robots to make the robots learn how to do new tasks over time and be able to do multiple tasks instead of just one task like the robots are able to do right now. Next, we're going to get into human-robot collaboration. Many people worry that robots are going to take all the jobs in manufacturing. They have a right to be worried, but robots will never be able to take all the jobs. They will be able to take some of them away, though. The goal of the robotic industry right now is to work with manufacturers and make it so that robots and humans can work side by side. The electronic manufacturing industry has already started using robots to make small parts while working with humans. Small parts can be very hard for humans to make, so using robots for this is extremely smart and helps make the process much more effective and efficient. The big concern with humans and robots working side by side has been safety. The robotic industry has put many safety features on these robots to make sure that they can't accidentally harm a human. New ways of working with robots. It is very important in manufacturing, specifically assembly lines, that if there is an issue, that it is taken care of immediately. But what if you could take care of the issue before it happened? Well, with this new technology being developed with robotics, this is becoming a reality. This technology will make it so that anywhere in the world you are able to monitor your robots on the internet to see if everything is running properly and if there are any maintenance issues that need to be taken care of. This could save manufacturers huge money if they are able to deal with this issue before it happens, so that assembly lines do not have to stop because of an issue. The next is improved robot senses. Improving robot senses is something that the robotic industry is currently working on, and when they are able to make robots have human-like senses, will make using robots even better. If robots are able to sense their surroundings, have better grip, and have 2D and 3D vision, this will make the impact robots have on manufacturing even bigger. With these senses added to robots, it will enable robots to be able to make decisions on what they should do next after finishing one task. Robots will be able to do more than one task, so it will make it that they aren't just used for one thing. A big thing these added senses will help with is making robots much more efficient with the small parts manufacturing, so that it doesn't take as long for robots to make each part. Next, we're going to talk about improved return on investment. Even though robots are extremely expensive, with the new technologies being added to robots each year, the benefits of owning robots outweigh their price. The more advanced robots are giving better return on investments because these robots can increase productivity, reduce overhead, provide flexibility, reduce waste, and increase quality, just to name a few. As more advanced robots are being made, this will help make manufacturers much more competitive and open the floodgates of more and more robots being used in every aspect of business. The future is very bright for robots in the manufacturing industry, as well as other fields in the near future. I, for one, am extremely excited to see where this future in robotics will go and how big of an impact it will truly have on the business world.